Lesson 5.5 looks at solving systems of equations algebraically. So up until this point, we've been learning about how to graph these systems. Sorry, not sure why it's doing that. There we go. So we're going to start by looking at the two ways of solving systems algebraically. We saw this in our kind of review of systems of equations from grade 10, but this time we're going to be dealing with possibly quadratic equations in addition to those linear equations. So still just two variables, but one variable might be showing up in more than one form. And we see this in the first example. So we've got 5x minus y equals 10. Great linear equation, totally familiar. Second equation is x squared plus x minus 2y equals 0. Now, where this kind of throws us for a loop is that we cannot combine these two terms with x in them. So all of a sudden, we have a situation where we've got x and x squared, and we need to be able to deal with both of them in a way that we can still solve for x, or that we can solve for y. So our two algebraic methods are still the same as in grade 10. So we've got substitution and elimination. I'm going to show you both for this first example, and you can kind of play around with which one makes sense depending on the scenario. So first, looking at substitution. Substitution means we're going to take one piece and replace it with another. So kind of like when I am sick, there is a substitute in my place. We're going to do the same thing here. It's always easier to rearrange our linear equation. If you want to make a note of that somewhere, go ahead. Just my personal opinion. Always easier to rearrange the linear equation. Because I've got x showing up twice in my quadratic equation, that means that if I were to isolate x, then I'd be plugging it in twice into my other equation. Whereas here, if I isolate y, it's just going to plug in to this in place of y in this particular term here. So that's what I'm going to do. So step one is rearrange. So I'm going to take my 5x minus y equals 10, and I'm going to get it so that y is positive, and that this is going to be 5x minus 10. Okay, you can take more than one step to do that. Okay, however many steps it takes to get y by itself, do what you need to do. To substitution. So we're going to sub in for y in the other equation. Okay, now the key is not to plug back into the original equation. That's not going to help you. So I'll make sure that this is going in lieu of, we started with minus 2y equals 0. Now I'm going to have x squared plus x minus 2 times 5x minus 10. Because y is the same as 5x minus 10. That's what that equal sign means. They're one and the same. And that equals 0. From here, I'm going to try and solve it like I would any other quadratic equation. Get x squared. I'm going to try and get some like terms collected. So minus 10x plus 20 equals 0. So that's x squared minus 9x plus 20 equals 0. That is nice and factorable, minus 5 and x minus 4. And so my values are going to be x equals 5 and 4. That's going back to that 0 property, where if two things are multiplying to equal 0, then one of those two pieces needs to be equal to 0, and you solve for x from there. Well, that's x. I am not done yet, though, because now I need to solve for y. Now, personally, I am going to check in by plugging into where y is already isolated. So step 3, other variable. So option 1, when x equals 5, y equals 5x minus 10, so it's going to be 25 minus 10, or 15. So that's one solution, 5 and 15. My other solution is going to be y equals 5 times 4 is 20 minus 10, which is 10. So 4 and 10. So those are my two solutions. Now I'm still going to have to verify, but before I'm going to verify that, I'm also going to show you how to solve this using elimination. So, slightly different way. Elimination is when we added or subtracted the equations together in order to cancel out one of our variables. In this case, I'm going to first start by just stacking them so I can compare them a little bit better. And I'm going to put my quadratic on top, actually. And then I've got 5x. I'm going to stack that right under my x, lone x term, not x squared, minus y equals 10. Okay, so when I look at this, no matter what I do, whether I add or subtract, nothing is going to eliminate my x squared term, which means there's no way of truly eliminating x from these equations when I combine them. That leaves me with only one other option. If I can't eliminate x, I have to eliminate y. Right now, they don't even have the same coefficient, so I can't even subtract them. So what I'm going to do is I'm going to multiply my second equation. I'm going to multiply by 2 so that I get the same coefficient, 2y versus 2y. They should be able to get them to cancel. Right now they've got the same sign. I want them to have opposite signs so that they actually will zero out. Every positive and needs a negative in order to equal 0. So what I'm going to end up with is I'm going to have my x squared plus x minus 2y equals 0. But then I'm going to have minus 10x plus 2y equals negative 20. I'm going to add these equations together. What does that allow me to do? Well, it leaves me with x squared. X minus 10x is negative 9x. These guys zero out, and it leaves me with negative 20 over here. If I go ahead and move that over now, so that I'm starting to work with my quadratic equation, I've got x squared minus 9x plus 20 equals 0. Well, you will notice that this equation and this equation are actually the same, which means I should end up with the same answer. So I factor this, x minus 5, x minus 4, 0, so x equals 5 and 4. Again, I would plug these values into one of my two equations. So I would say 5 times 5 minus y equals 10. So that's going to be negative y equals 10 minus 25, or positive y equals 15. And that is when x equals 5. When x equals 4, we would have 5 times 4 minus y equals 10. So we got negative y equals 10 minus 20, or y equals 10. So either way, my two solutions are 5 and 15 for one coordinate, and 4, 10 for my other coordinates. So whichever strategy you want to use is totally up to you. Sometimes substitution lends itself pretty well. Other times elimination seems to be the better choice. But that is completely your call. What we do need to do is verify that these work. So I checked my y values by plugging into my linear equation. So I'm going to verify these points by checking them in my quadratic equation now, just to make sure that they both work in both equations. So when x equals, or specifically checking point 5 and 15. We've got x squared. Let me just scroll up so make sure I got the right equation. Plus x minus 2y. Plus x minus 2y equals 0. So I need this to be true. So we've got 5 squared plus 5 minus 2 times 15 equals 0. Well, that's 25 plus 5 minus 30 equals 0. That is true. So this point is good to go. We'll do the same thing for 4 and 10. So we've got 4. I've got my equation written over here already, so I'm not going to rewrite it again. 4 squared plus 4 minus 2 times 10 equals 0. 16 plus 4 minus 20 equals 0. That is true. So both of these points are entirely valid. Good. Check. That means that my final answer, my solution, are going to be 5 and 15 and 4 and 10. There's no word problem, so there's no excluding values, so I'm good to go. As long as my verification works, I'm fine. Our second example here asks us to do the exact same thing. The only difference is that now we are dealing with two equations that are both quadratics. That means that I will technically be able to cancel out my x's, potentially. But I need to kind of check that first. Right now, if I doubled my x squared value, I would only have 2 x's. That would not cancel with the 4 x's here. Likewise, if I halved this equation, I would have 3x squared. Great, that cancels with x squared, but it doesn't cancel with my x's here. So still, if I'm using elimination, I'm going to try and eliminate y. So that's the strategy I'm going to use. Okay, so we've got 3x squared minus x minus y, and I'm just going to move that 2 onto the other side so that all my constants are on the same side of the equal sign. I'm also going to switch the signs of my second equation. Why would I do that? So that my y's have opposite signs, so when I go to add these equations, they will cancel out. So I'm going to have negative 6x squared minus 4x plus y equals negative 4. That leaves me with, adding the second equation, that leaves me with negative 3x squared minus 5x equals negative 2. Now when we deal with quadratics, we want everything on one side set equal to 0 so that I can try and either factor or use my quadratic equation to solve for x. I want it in general form. So this time I'm going to move everything to the right so that I get that positive x squared term again. So I'm going to get 3x squared plus 5x minus 2. And that's going to work for me. Now, this is factorable. I'm going to use my kind of splitting up strategy. If you weren't a fan of that, go ahead, pause the video, use your own strategy. Really practice factoring. Okay, so here we go. I get my final answer of factored 3x minus 1 and x plus 2. Again, using this method, I'm going to take out the negative here to ensure that I get the same thing in both my brackets there. Once I've done that, I can tell you that my x values are going to be 1/3 and negative 2. From here, I'm going to plug back into one of my equations. I'm going to use the one that has a 3 in it, just for the ease of my sanity. I've got 3x squared plus x minus y, and what was the rest of it? Minus 2 equals 0. And again, I'm verifying this. But before I can verify, I'm not actually done. So I'm going to use my other equation to solve for y. So 6x squared plus 4x minus y equals 4. I'm going to rearrange that now before I start plugging in. 4x minus 4 equals y. Now I can plug in. So when x equals a third, then I've got 6 times 1/3 squared plus 4 times a third minus 4 equals y. So that's 1/9. It's going to be 2/3 plus 4/3 minus 4 times 3 is 12/3. Okay, and I want to get common denominators for adding and subtracting purposes. That's why I've converted 4 to 12/3. From here, 6 minus 12 is going to be -6/3 or -2. Okay, so that means my coordinate is -1/3 and not negative a third, just a third and -2. For my other equation, or for my other value, x equals -2. I'm going to plug in here. So I've got 6 times 4 is 24 minus 8 minus 4. So that's -12, so that gives me 12. -2 and 12. Remember, x always gets listed first when you're writing coordinate points. So I think these are both my solutions. Now I'm going to verify by plugging into my other equation. Zoom out a little bit. That's me. There we go, so I can see everything at the same time. So checking a third and -2. 3 times a third squared plus a third minus 2. It's supposed to be subtracting 2. Minus 2 minus -2. Okay, so be careful with that one when you're plugging in y. That's why I like to put it in brackets so I can double check my signs before I move on. So I've got 3 times the 9th, which is a third, plus a third, and then we've got plus 2 minus 2. Those cancel out. And so I'm getting something funny's going on here. Let me double check this. Okay, and this is why we verify, although in this case it actually was just a human error. This should be minus because this equation is subtract x. If I'm not mistaken, yes, subtract x, which means we're subtracting here. 1/3 minus a third also cancels out, which means this is true. Checking our other coordinate points, so that's true. We've got 3 times -2 squared minus, okay, and I got the right sign, -2 in there, minus y, which is 12, minus 2 equals 0. So -2 squared is 4 times 3 is 12. Negative and negative is positive, so plus 2 minus 12 minus 2. We get these two canceling out, these two canceling out, all set equal to 0, so that's true. So both of my coordinates are true. Yay! Next question, let's take a look at this guy. Determine two integers such that the sum of the smaller number, so let's use n for that one, and twice the larger number, I'm going to use L for that, is 46. Also, when the square of the smaller number, okay, and decreased by 3 times the larger, the result is 93. Okay, so I've gone through, I've circled all my operators, I've labeled where I'm talking about different variables, which variable, and I've attached a letter to it, and then I've underlined kind of what my equation is going to be set to. So part A, it just asks you to write the system. What that means is literally write an equation to describe what is being described here. So put it in math language instead of the English language. So sum means I'm adding. What am I adding? Sum of the smaller number, so it's n, and twice the larger number. So 2 times as many l's. And that is implying our equal sign. That is equal to 46. Also, so completely separately, but using the same values, when the square means the power of 2 of the smaller number, so n squared, is decreased means subtracting, we're going downward, by 3 times our larger number, the result is 93. These are some pretty sizable numbers if we're subtracting and we're still getting 93. So we look at this and we say, okay, well, now what? Well, we're done part A. All it says is just write the system of equations. So we're done. Part B is actually solving it. So here, again, I'm going to use elimination because that by default is just my preference. And although, you know what, let's do substitution just to make sure that we are comfortable with both ideas. So for substitution, what I'm going to do is I'm going to number my equations so that I know. I'm going to rearrange. That's the first thing I'm going to do. So n equals 46 minus 2l. Then I'm going to substitute, and I'm going to call this equation 3. So I'm going to sub in 3 for n. What that's going to look like is in lieu of n squared, I'm going to have 46 minus 2l squared minus 3l equals 93. And I'm going to solve for l from here. So 46 squared is 2,116 minus 92 times 2 is 184l plus 4l squared minus 3l equals 93. Now again, I'm dealing with a quadratic, so I need to get it in general form. So I've got 4l squared minus 187l, and then I've got 2,116 minus 93 gives me 2,023 equals 0. Okay, so I'm dealing with some pretty ugly numbers here, like they're huge. So what I'm going to do is I'm going to use my quadratic equation because there's no way I'm messing about with this and finding my L. So L equals negative b plus or minus the square root b squared minus 4ac all over 2a. In this case, that's going to be negative 187. And again, I'm doing all my brackets and everything to make sure I include all my signs properly. Square root of 187 squared minus 4 times 2023. All divided by 2 times 4. So it's 187 plus or minus. Now I'm going to get what's under that square root here. So 187 squared minus 4 times 2023 gives me a positive number of 2601. If I take the square root of that, I get 51 over 8. So actually this is looking like it might have factored nicely. I'm going to have two solutions here. So I've got 187 plus 51 and then divided by 8. I'm going to keep it in fraction form. 238 over 8. Or I could subtract 187 minus 51, gives me 136 over 8. This one is nice. That gives me 17. This one I'm going to rewrite as a decimal. Okay, so that's L. Now I need to go back and solve for N. So remember, N plus 2L gave me 46. Yes. So N equals, and we can go back to that rearranged formula as well. So 46 minus 2L. Option 1 is when L equals 29.75. We've got N equals 46 minus 2 times 29.75. Or negative 13.5. Option 2 is that L equals 17, in which case 46 minus 2 times 17. So both of those numbers are completely legitimate. Now I go back to my question just to check to make sure that this makes sense. Determine two integers. Integers can be positive or negative, which means that all of these values are true. N is always less than L, which matches my original description of N being my smaller number. So my solutions are that it could be negative 13.5 and 29.75, or it could be 12 and 17. Now, of the two, I like the second answer better, but technically both are possible. Last example, if I'm not mistaken. Yeah. Okay, so during a basketball game, Ben completes an impressive alley-oop. Okay, which means that he goes running in and jumps up and just kind of volleys the ball into the basket. If you don't know what an alley-oop looks like, it's pretty impressive. You should definitely go on YouTube and look it up. Okay, so from one side of the hoop, his teammate Luke lobs a perfect pass towards the basket. From there, Ben jumps up, catches the ball, and tips it into the basket. The path of the ball throw by Luke can be modeled by this equation. Okay, this is Luke. Okay. The path of Ben's jump can be modeled by this equation. So this is Ben. Okay, so D represents the horizontal height of the ball, the horizontal distance, sorry. Okay, and H represents the height of the ball from the floor. Okay. Height of the ball from the floor, height of his hand from the floor, okay? And when his hand meets that ball, that's when Ben gets the ball and then does his alley-oop. So to give you a picture of this, we've got Luke standing somewhere outside of the key, and Ben, basket is here. Okay, remember, Miss Conrad is not an artist. Ben comes jumping in, flying in, and he is going to tap the ball in. So the basket, or the ball, gets passed to Ben, and Ben then dunks the ball. Okay, so that's what that looks like. So let's solve this. Well, algebraically, this could be interesting. I am going to do this by elimination. So I've got d squared minus 2d plus 3h equals 9. And I've got 5d squared minus 10d plus h equals 0. So Luke and Ben. Okay. Because the ratio is actually the same between d to d squared, d to d squared, and d to d squared in both equations, it's 2 to 1, I can actually eliminate d and solve for h. So that is exactly what I'm going to do. So I'm going to multiply this equation by -5 so that I change my signs and I get matching coefficients for all my d values. So now I've got -5d squared plus 10d minus 15h equals -45. And 5d squared stays the same, minus 10d plus h equals 0. So when I add these all together, all of this cancels. And it leaves me with -14h equals -45. Or h equals, it's going to be just over 3. 45 divided by 14, 3.2. It says to the nearest hundredth, so I'm going to keep 2 decimal places. Height above the floor in meters. Awesome. That's pretty high. Now, where is this happening? Okay, remember D is the distance from the center of the hoop. Okay, so this here, right here, is when D equals 0. Just remember that. Okay, so we plug in H into one of these two equations. I'm going to go with the one with fewer coefficients, so back into Luke's equation. So D squared minus 2D plus 3 times 3.21 gives me 9. D squared minus 2D plus 9.64 equals 9. So this is going to be D squared minus 2D plus 0.64 equals 0. All right, well, this could go a couple ways. You can use your quadratic equation to solve for this, where A equals 1, B equals -2, and C equals 0.64. You could also use our strategy of like multiplying by or dividing by 0.64 to eliminate any decimals, see if we can, or multiply by 100. That would be an option. I'm going to work with just my quadratic equation. When I plug this into my quadratic equation, I get two options. I get 1.6 or I get 0.4. The tricky part about this is that it's not going to be both. Ben is not in two places at once. So which one makes more sense? To be 1.6 meters from the hoop or 0.4 meters from the hoop? Well, based on my picture, I'm thinking 0.4 meters is the more legitimate thing, because how's he going to be able to get his hand basically on the rim, almost like a slam dunk, if he is 1.6 meters away? Probably unlikely. So I'm going to say my solution is 0.4 meters 0.4 and 3.21. Now we can include our units like that. Or we can talk about it in terms of distance from basket and height from ground. Okay, what assumptions did I make? Well, I made the assumption that Ben was closer to the basket than far away. Okay, so that's how we solve these algebraically. I know that was a number of examples that took a long time, but I wanted to make sure you had a taste for a few different ways of doing this. So you can do some practice questions, and then you're ready for your next assessment.